Let's try to solve this problem here. The jet engines of an airplane generate a thrust force of 700 kilonewton. Okay, thrust force is the force that propels an airplane forward. Okay, push the airplane forward. So if you want to imagine the situation, you can think of it as you have a plane. Okay, this is your plane now. This is the tail, this is the wing of the plane. The plane here is generating a push. It is pushing itself forward with a force of 700 kilonewton. Okay, how do we push itself forward? Then well, there's turbine on both sides, right? Okay, then you have there's turbine on both sides, so they generate a thrust of 700 kilonewton to push the jet plane forward. So now they ask, what is the power of the airplane in megawatt when it is flying at 250 meter per second? Okay, so you know that if you are pushing yourself forward, the plane should accelerate. Okay, the plane should be accelerating. So the velocity or the speed should be changing throughout this process. You go from slow to become fast. But now they're asking the power of the airplane when the plane is at 250 meter per second. So they're asking for the power at a specific moment in time. Why do we know a specific moment in time? Because we know that the speed is changing. The speed is changing from slow to fast because there's a net force over here. The speed is changing, but they are asking the power at a specific speed. Power at a specific speed means by they are asking for a specific moment in time. So this is actually instantaneous power. So to solve instantaneous power, we already learned from our lecture that instantaneous power, P, there's no AV down there. AV means by average. The power here will be equals to the dot product between the force and the velocity, in which if you expand it, it will be Fv cos theta. Okay, we know the force is the thrust force over here and it's 700 kilonewton. So 700 times 10 to the power 3. You know that the speed that we are interested in is 250 meter per second. Let's know without the unit. Okay, 250 meter per second. And cos theta, what's the angle between the force and the velocity? You know that the object is moving forward. So the velocity will definitely be pointing in the same direction as the force. So because they are the same direction, you know that theta will be equals to 0. So through a simple calculation, I am sure you are able to find the answer to be 1.75 times 10 to the power of 8 watt, which if you transform it, it become 1.75 times 10 to the power of 2 times 10 to the power of 6. Why do I do like this? Because this here will be mega. So now this is megawatt. So you get 1.75 times 10 to the power of 2 megawatt, or you can write it as 175 megawatt. Okay, so a very simple calculation to show the instantaneous power when the speed is 250 meter per second. So that's how you solve this question involving instantaneous power. Thank you very much.